Right, now we're looking at examples 4 and 5. So I've written them out in this document for you. So I would recommend taking a moment right now to pause this video and copy them down. I've added in a little bit to example 4 that the textbook didn't originally have. I just want to make sure that we are going through one more example problem talking about domain and range. So take a moment, divide your paper in half, copy down example 4, copy down example 5, and then hit play when you're ready to go through them. I'd also recommend maybe trying them on your own first as well, seeing if you can identify these pieces and answer the questions without looking at the answer yet. All right, so hopefully at this time maybe you've given them a try on your own first, but I want to go through example 1. I apologize if it was a little messy and hard to read, but this was supposed to be the point 0, 5, so hopefully that didn't look like a 6 when you were copying it down. Looking at the domain is all of those input values, so all of those first numbers that were written. So the 0, the 1, the 2, and the 3. So when you're writing down domain, you're just writing down those list of first values or x values. Range is the second numbers. So 5, 5, 5, and 5. They're all 5. So when we write down our range, you don't have to write the 5 every time. You just have to write it once. Now this is a unique one. We want to know if this is a function. That's what the big question is. Remember, function is defined as every x value has its own unique y value. So my x value of 0 is not repeated in any other ordered pair, and so the x value of 0 is only paired with the y value of 5, which is unique. The x value of 1 is only paired with a 5. 1 doesn't go to any other value. The x value of 1 is only being paired with a 5 in this ordered set, so that is considered unique. You might be wondering, but 5 was repeated or is being repeated as a y value in all these ordered pairs, and that's okay. So you might want to make a note off to the side somewhere that y values can repeat as long as they have different x values. Another way that you could maybe word this is you could say x values can't repeat. Just like in that last problem, our x values repeated and gave us different y values, and that was not okay. That meant that it was not a function. Here, though, the x values are all going to their own unique y values for that value of x, which I know that can be kind of confusing, okay? So I know that this problem or this example is a little tricky. I want to show you a visual as well to see if maybe that will help. If I write out my domain and my range, I know that all my arrows are pointing to one number, but what we need to make note of and what we're looking at is that the arrow, there's only one of them attached to each domain value. There's only one arrow attached to each domain value, which means that this is a function. If you were to create this visual for domain and range and connecting these arrows, and you have multiple arrows coming from a domain value, that's when it's not a function. When you have multiple arrows going from a domain value, it is not a function. But as long as only one arrow is connecting from a domain number to a range number, even if they're all the same, it is a function. So on this one, is it a function? We will say yes. Okay, all of those x values are only connected to one y value, meaning my value of 0 is not going to different values. It's only going to 5. My value of 1 is not going to multiple numbers. It's only going to a value of 5. All right, let's take a look at example 5 next. Is this a function? So what we want to look at in that diagram like I created in example 4 is something you can create for all of them. So I'm going to create this visual diagram again. And if you don't like using this visual diagram, you don't have to use it, okay? This is just one thing. So the domain is all of the x values or all of the starting numbers. Okay, I'm going to write them in order from smallest to largest though. So 0 is my smallest domain value, then 5, and then 8 is repeated twice, but I'm only going to write it once. My ranges are all of these second values, and again I'm going to write them in order from smallest to largest. So -9, -4, -3, and -2. You don't have to write them in order from smallest to largest. It just can make it easy. Now I'm going to start connecting my arrows from my domain values to my range values. So 0 is paired with -9. So I draw my arrow. 5 is paired with -3. 8 is paired with a -2 and a -4. Notice how my 8 has 2 arrows coming off of it, going to 2 different numbers in my range column. Because of that, that means that this is not a function. So we would say no, this is not a function. My x value of 8 is paired with 2 different y values. It's paired with multiple y values. Remember, domain is your x values, range is your y values. So, because that value of 8 is going to 2 different y values, -2 and -4, this is not a function. And if we compare that to what we did in example 4, none of my domain values in example 4 were going to multiple numbers. Okay, 0 only went to one value, 1 only went to one value, 2 only went to one value. But in example 5, I have a value of 8 that has 2 arrows coming off of it, which is why example 5 is not a function. So at this point, you have the ability to work on some of the review problems that are in the textbook, check your answers to those, and once you feel like you have a good understanding and you don't have any questions for me, or if you do, you ask the questions, please, then you can begin working on the assignment that's posted in Google Classroom for Concept 1.